Right now, on the outer edges of our planetary system, a unique cosmic event is unfolding. Approaching our home from the depths of the galaxy is a guest comet named 3 Atlas. This wanderer was not born in the neighborhood of our Sun, but somewhere far beyond the solar system, and now, its path lies past Jupiter, the most massive planet in our stellar family. With each passing day, the distance between the comet and the gas giant shrinks, and the closer they get to each other, the stranger the behavior this interstellar object demonstrates. Something unusual is happening right before our eyes. This comet behaves completely differently from its brethren in the solar system. It formed under different conditions, under the light of a different star. Its activity differs radically from everything astronomers have studied for decades. We see its color changing day by day. We observe the transformation of gas clouds around it. And instead of a classic comet tail, we see chaotic jets of matter erupting in different directions. In this video, we will break down exactly what is happening with Comet 3 Atlas, learn what role Jupiter plays in this cosmic drama, and understand what knowledge about the structure of the universe this encounter can offer us. If you are interested in such discoveries, support the channel with a like and a subscription. It is really important to us. Now, let's dive into the details of this amazing story. To understand the scale of what is happening, we need to grasp the main point. This comet is fundamentally different from all others. Most comets in our system are icy debris left over from the formation of planets. They orbit the Sun in predictable paths. When such a comet approaches our star, solar heat evaporates its ice and gases. This is how the famous tail is formed. The chemical composition of these objects is well studied, and their behavior is understood and expected. But 3 Atlas is a completely different case. It is an interstellar object. It came to us from the outside, perhaps from the vicinity of a distant star, or from unexplored regions of the galaxy. We call it a comet, more out of habit than due to real resemblance. Astronomers do not see a clear tail pointing away from the Sun. Instead, gas surrounds the object from almost all sides, and jets erupt from it unpredictably, in many different directions. This alone speaks volumes. Whatever the core of 3 Atlas is made of, it reacts to solar energy completely differently than any comet familiar to us. Every new observation of this object brings surprises, and this is just the beginning. One of the most striking features of the comet is its ability to change color. One day, telescopes capture an orange glow. A few days later, the object becomes green. This is not an instrument error or a visual effect, it is a real chemical clue. The color change indicates that different substances on the surface or inside the nucleus are activating at different times. Perhaps this is due to fluctuations in temperature, radiation levels, or the internal structure of the comet. The problem is that the exact chemical composition of 3 Atlas remains a mystery. We can usually identify ordinary comets quickly through spectral analysis, but this comet acts like a substance with unknown properties. It reacts unpredictably. Now that the comet is approaching not only the Sun, but also Jupiter, conditions around it are becoming even more extreme. Radiation is intensifying, gravitational forces are increasing, and the object responds to these challenges by changing its appearance time and again, as if showing us different facets of its nature. Now the story reaches its climax. Jupiter is not just a big planet, it is a real gravitational monster. Its mass is so huge that you could fit more than 1,000 planets like Earth inside it. Jupiter's sphere of influence extends for millions of kilometers. In this region of space, any passing objects experience colossal forces. Their trajectories bend, their speeds change, and sometimes they are captured by gravity to become moons or are destroyed, as happened with Comet Shoemaker-Levy 9 in 1994. Comet 3 Atlas is now passing through a zone where Jupiter's influence can no longer be ignored. If its speed were lower, there would be a real risk of capture. But this comet is moving incredibly fast, much faster than ordinary comets. Most likely, this will save it from the gravitational trap. However, high speed does not make the object invulnerable. Even a fast-moving body can be altered by such a powerful force. The slightest deviation in trajectory could reveal hidden features of the comet's internal structure. Besides gravity, Jupiter creates another challenge: an intense radiation environment. The planet's radiation belts extend for hundreds of thousands of kilometers. Charged particles spin here at enormous speeds, creating conditions that few celestial bodies have experienced up close. Although 3 Atlas will likely not pass through the most dangerous zones, it will still find itself in an extreme environment. And here lies the main mystery. We do not know how an interstellar object with a known chemistry will react to Jupiter's radiation. Observations show that the comet is already switching between different modes of activity. Sometimes it is shrouded in a vast gas cloud. Other times it shoots jets in several directions simultaneously. And occasionally it demonstrates both processes at once. Astronomers are watching closely. Will this activity intensify as it gets closer to the giant? Will its character change? Or will we see something completely new? We are observing not just a comet flying past a planet. We are witnessing the testing of an alien object by one of the most extreme environments in our system. With every day of observation, it becomes increasingly obvious 3 Atlas does not behave like a normal comet. It has no simple division into a front and back section. Instead of a distinct tail, images show gas almost symmetrically surrounding the nucleus. Sometimes this looks like a classic coma glowing cloud around the central body. At other moments, the gas seems to be pushed out ahead of the object, and on certain days, narrow, intense jets erupt simultaneously in several directions, following no logic. This constant switching between different states suggests that the comet is not just passively evaporating, it is actively reacting to external conditions. Its surface activates in different ways, making every new image different from the previous one. When scientists compared images taken days apart, they found a pattern. The comet cycles through at least 3 different states. First, the object is shrouded in a diffuse cloud of gas, like a glowing cocoon. Second, focused jets shoot outward, cutting through space like directed streams. Third, both features appear simultaneously. A dense coma and sharp jets coexist. These are not minor variations, they are dramatic shifts that indicate internal processes switching on and off. By enhancing the contrast on the images, observers clearly see gas structures forming and dissipating. Such variability is unusual even for solar system comets, but for an interstellar object, it is absolutely extraordinary. This suggests that 3 Atlas is not a simple frozen relic, but a dynamically active body with a complex internal structure. As the comet approaches Jupiter, the surrounding environment changes fundamentally. The gravitational field strengthens, tidal forces increase, and the plasma environment becomes more intense. For an ordinary solar system comet, these factors are already significant. For an interstellar object with a known chemistry and structure, this is a transition into a completely new mode of existence. Scientists cannot predict what will happen next. Will proximity to Jupiter trigger new outbursts, suppress existing activity, or destabilize part of the comet's surface? This is why this close approach is so important. It is not just an astronomical observation, it is a natural experiment, where an alien body is subjected to one of the most extreme planetary environments available for our study. The uniqueness of the moment also lies in the fact that the scientific community openly admits there are no ready answers. Astronomers are studying 3 Atlas in real time along with us. Every new image adds a fragment to the big picture, and sometimes it forces a revision of conclusions made just a few days earlier. This is a rarity in astronomy. Usually, objects are studied after the fact, when their behavior has stabilized. Here, the data is coming in right now. The object is active, and its interaction with Jupiter continues to unfold before our eyes. Will the comet maintain stability? Will it change dramatically or reveal a completely new type of activity as it flies past the giant? One thing is certain. We're observing a phenomenon we have perhaps never seen before. An interstellar guest is being shaped, tested, and revealed under the gravitational shadow of Jupiter. A factor constantly mentioned in scientific discussions is the comet's speed. The object is moving significantly faster than most comets we have ever observed, and this speed might be the key to its survival. In the past, slower comets that came too close to Jupiter gradually deviated from their path, were captured, stretched, and destroyed. A prime example is Comet Shoemaker-Levy 9, which broke into fragments and crashed into Jupiter in 1994. But 3 Atlas is different. Its high speed allows it to pierce through Jupiter's gravitational field rather than sinking into it. However, speed does not mean complete invulnerability. Even a fast-moving body can experience subtle changes, slight deviations that will become apparent only with time. Researchers track these microscopic shifts because even a minimal change can indicate how the object reacts internally to the colossal gravitational stress. Hanging over this entire story is one unanswered question. We still do not know exactly what 3 Atlas is made of. Its chemical composition remains a riddle, making any predictions extremely difficult. Jupiter's environment is not gentle. Intense radiation, charged particles, a complex magnetic field, all this creates a real stress test for any passing body. An ordinary comet would react predictably, slightly increase in brightness or release more gas. But 3 Atlas is unfamiliar to us. Its changing colors and irregular gas behavior point to a chemical nature, capable of reacting unpredictably. As it nears Jupiter, certain materials within the comet may suddenly activate, while others stop reacting entirely. That is why astronomers call this a wait-and-see scenario. Nature is conducting an experiment that we ourselves could never safely reproduce. Observers continue to be amazed at how consistently the comet refuses to meet expectations. One day it looks calm, wrapped in a soft gas cloud. The next day it seems aggressive, shooting jets in directions with no obvious explanation. This is not noise in the data, this is its real behavior. When scientists line up images taken days or weeks apart, they do not see smooth evolution, but sharp, jumpy transitions. This challenges the idea that cometary activity is driven only by gradual temperature changes. Instead, it suggests the crossing of internal thresholds, as if switches are being flipped inside the object. As Jupiter dominates the foreground more and more, the question is no longer if the comet will change. The question is how dramatically and suddenly it might happen. One approach scientists use to make sense of this encounter is to view Jupiter as a kind of cosmic filter. Objects flying through its vicinity cannot leave unchanged. Gravity, the magnetic field, and radiation acts together like a stress chamber, separating stable structures from fragile ones. As 3 Atlas moves through this region, every irregularity in its internal structure is put to the test. Weak layers may crack, volatile pockets may suddenly erupt. Internal tensions accumulated over millions of years in the interstellar void may finally find a release. That is why astronomers are focused not only on finding dramatic explosions, but also on the subtlest changes. Even a small shift in the character of gas emissions, or minimal fluctuations in brightness could testify that Jupiter is actively transforming the object during the flyby. Part of the charm of the current moment is that we have never observed exactly this scenario before. Interstellar objects are rare in themselves, and catching one during a close encounter with a giant planet is an exceptional event. Most of our knowledge about comets near Jupiter is based on observations of bodies formed in the solar system. They have similar formation conditions and similar chemistry. 3 Atlas is completely different. It arrived with a completely different history, carrying materials and structures formed far from our Sun. This means that even familiar processes, tidal forces, or radiation effects can yield unexpected results. Scientists are watching not just a comet near Jupiter. They are watching how alien matter behaves in a planetary environment it was never designed for. Another reason for the importance of this flyby is the possible temporary nature of some effects. Certain reactions may occur exclusively within a narrow time window, when distance, radiation background, and gravitational forces align in a unique combination. Jets may flare up for a brief moment and then fade. Gas clouds may expand and dissipate before telescopes can fully capture them. Structural changes may leave subtle traces that are easy to miss if you don't know what to look for. That is why observers are documenting absolutely everything, even what seems insignificant. In moments like these, the smallest details often turn out to be the most critical clues, revealing processes that happen only once in the object's entire journey. As 3 Atlas is studied near Jupiter, another realization begins to form in the scientific community. This object may not be unique. It might be just the first of many interstellar guests that we have learned to observe in detail. With the improvement of telescopes and detection systems, such encounters may become more frequent in the future. What we learn now will determine the methodology for interpreting every subsequent interstellar object. If 3 Atlas demonstrates that such bodies are capable of maintaining activity, unpredictability, and chemical complexity near massive planets, then future discoveries will cease to be seen as oddities. They will be welcomed as messengers, each carrying information about distant star systems. During the comet's movements through Jupiter's sphere of influence, gravity acts not just as a trajectory character, but as a probe of internal structure. Tidal forces act unevenly, stretching one side more than the other, creating tension. This reveals whether the body is monolithic, fragmented, layered, or a loosely bound conglomerate. For ordinary comets, the results of such impacts are often predictable, but the reaction of 3 Atlas remains uncertain. Its variable gas emissions suggest independently activating internal reservoirs. This turns Jupiter into something like a giant scanner, silently testing the internal structure of the object. Besides gravity, Jupiter possesses one of the most powerful magnetic fields in the solar system. Charged particles spin in its vicinity at colossal speeds, creating a cosmic environment with no analog near Earth. Even flying at a distance, the gas emissions of 3 Atlas will interact with these magnetic forces. This can distort their shape and direction. This interaction potentially explains why the jets sometimes look deformed or asymmetrical. For scientists, this is a priceless opportunity to observe how matter from another star system behaves inside a magnetic field generated by a giant planet. Growing interest among observers is linked to the question: will 3 Atlas emerge from this encounter in the same state? Stability is not guaranteed. Even without a catastrophic breakup, internal rearrangements could forever change the character of its future activity. Volatile reservoirs may deplete or be exposed. Structural weaknesses may worsen. What looks stable today may behave completely differently after Jupiter's influence is left behind. This makes the post-encounter phase just as important as the event itself. Scientists will be watching not only what happens near the planet, but also the consequences of this interaction. At this moment, it is clear. The flyby of 3 Atlas near Jupiter is not an instantaneous event, but a prolonged process. Every observation builds on the previous one, sometimes confirming expectations, and sometimes completely refuting them. The object continues to surprise not with a single dramatic gesture, but with a steady succession of subtle but highly significant changes in behavior. This is what makes this story so gripping. We are not present for the reading of a finished chapter in an astronomy textbook. We are watching this chapter being written before our eyes, from observation to observation, looking at the big picture. It is impossible to ignore a fundamental truth. Comet 3 Atlas is not just flying past Jupiter. It is undergoing a trial. Gravity, radiation, magnetic fields, extreme conditions, all these factors are acting on an object that was not born here, that did not evolve under the light of our sun, and that does not follow the rules we considered universal. Every jet, every color shift, every structural transformation is a meaningful reaction, not an accident. Jupiter acts as a cosmic laboratory, and 3 Atlas is the experiment revealing the behavior of interstellar matter. This does not mean something supernatural is happening. Science remains on the solid ground of facts. But it means something equally important. Our understanding of comets, interstellar objects, and cosmic wonders is incomplete. 3 Atlas demonstrates that bodies from beyond our system can be faster, more complex, more reactive, and more unpredictable than anything we have catalogued before. It is not just a frozen relic drifting without aim. It is an active, responsive body, continuously transformed by forces that challenge our models. Let's draw a historical parallel. For centuries, sailors were convinced that beyond the horizon lay an empty ocean, until new ships returned with maps that changed the perception of the world. 3 Atlas is one of those ships. It arrives from places where we have never been, passes through a gravitational giant like Jupiter, and leaves behind data that transforms our understanding of every future interstellar guest. Will it remain a rare anomaly, or become the first representative of a completely new class of objects? One thing can be stated with certainty. After this encounter, we will never look at interstellar comets with the same eyes again. If you watched this video to the end, comment with your city below.